welcome back to Max with RP. Today we are going to solve more problems based on the notions of increasing and decreasing functions. So we were in the earlier video we had already solved some problems, so I'm just continuing. We will look at the new problem here. Find the value of x for which y equal to x into x minus 2 the whole square is an increasing function. So we have f of x equal to x square into x minus 2 the whole square. We have to find that value of x for which f is an increasing function. We all know that a function is increasing if f dash of x is greater than 0 for all x in that particular interval. Okay. So let us first find f dash of x. F dash of x will be, so as you can see, this is x square into x minus 2 the whole square. So if I differentiate, I'll get x square into 2 into x minus 2. Product rule, I'm applying product rule. Plus x minus 2 the whole square into derivative of x square, which is 2x. So 2x, x minus 2 is common. So I've taken out 2, I've taken out 1x and x minus 2. What will be left is x. Here I have taken x minus 2, I have taken 2x. So I'll be left with x plus x minus 2. So this is again 2x minus 2. So that 2 I can take and combine. I'll get 4x, x minus 2. This is 2x minus 2. When I take out 2, I will get x minus 1. So this is the derivative. Okay. Now we can divide the number line. Okay. Minus infinity to infinity. Okay. Using those values for which f dash of x is 0. So f dash of x is 0 implies x can be 0, 1 or 2. So we have 0, we have 1 and we have 2. These are the critical points. What do you mean by critical points? These are the points where if you draw tangent to the curve, it will be parallel to the x-axis. F dash of x equal to 0 are called critical points or turning points because they are the values of x, which to the left and right of which the behavior of the function can change from increasing to decreasing. Okay. Now let us say, how do you check whether a function is increasing or decreasing? So we have interval sine of f dash of x and nature of f of x. Okay. Now minus infinity to 0. Okay. What is your f dash of x? This is my f dash of x. So I need to substitute here. So let me take any value between minus infinity to 0. So let x be minus 1. What is f dash of minus 1? F dash of minus 1 will be, this will become minus 4. Minus 1 minus 2 will be minus 3. Minus 1 minus 1 will be minus 2, which is negative. So the function is decreasing in minus infinity to 0. Okay. Now between 0 to, now I have to choose a value between 0 to 1. I can take 0.5. Okay. Let x be half. F dash of half will be what? This is 4 into half. This is positive. Half minus 2 will be negative. half minus 1 will be negative, which is going to be positive. So the function is increasing from 0 to 1. Okay, next let us choose a value between 1 to 2. F dash of 1.5. What will be f dash of 1.5? What is f dash of 1.5? If I put 1.5, this is positive. This will be 1.5 minus 2 is negative. This is positive. So f dash of 1.5 is negative. So between 1 to 2, the function is decreasing. What about beyond 2? What is f dash of 3? This is positive. 3 minus 2 is positive. 3 minus 1 is positive. But the function is increasing. Okay. So you can divide the real line into minus infinity, comma 0, 0, comma 1, 1, comma 2, and 2, comma infinity. Minus infinity to 0, the function is sign of is negative. So the function is decreasing. 0 to 1, the sign is positive. The function is increasing. 1 to 2, it is negative. So it is decreasing. 2 to infinity, it is positive. The function is increasing. So what are the values of x where the function is an increasing function is increasing is 0 to 1, 0 to 1, union 2 to infinity. Okay. Now, because it says increasing, okay, so you can also include the value where it is equal to 0. So I can actually have 0 closed interval. If it is increasing, then I can use closed interval. 0 to 1 union, at 2 also it is closed. Strictly increasing means I should use only the open interval. Strictly increasing means greater than 0. Increasing means f dash of x is greater than or equal to 0. So we are using the sign of f dash of x to determine the nature of f of x. Is it clear? Closed interval. Now we have f of x equal to cos square x, and the closed interval we want to find where it is increasing or decreasing or the nature of the function in the first quadrant. Okay, so f of x is cos square x. So f dash of x will be 2 cos x chain rule into derivative of cos x, which is minus sin x, minus 2 sin x cos x, which is minus sin 2x. Okay. Now, what are the critical points? F dash of x equal to 0 implies sin 2x is 0. Where all sin theta is 0? 0 when x is 0, right? When 2x is pi, 2 pi, etc. Okay. So x is 0, pi by 2, pi, etc. So these are the values where sin 2x is 0, where the derivative is 0. Now if you take, but we are only interested in 0 to pi by 2. 0 to pi by 2. So let me take a value here. So let x be pi by 4. What is f dash of pi by 4? F dash of pi by 4 will be, what is your f dash of x? This is your f dash of x. So minus sin of 2x, 2 into pi by 4. Sin pi by 2 minus sin pi by 2, which is minus 1, which is less than 0. So if it is less than 0, it will be what? What can you say about f of x? It is decreasing. Therefore, f is decreasing in 0 to pi by 2. How did we do? We differentiated. We got minus sine 2x. If sine 2x equal to 0, we got x equal to 0, pi by 2, pi, etc. Then we are only interested in the interval 0 to pi by 2. So within that interval, I took a value pi by 4. I look at the sign of f dash of pi by 4. It will be minus sine 2 pi by 4. 2 pi by 4 is pi by 2. Sine pi by 2 is 1. So minus sine pi by 2 is minus 1. So f dash of pi by 4 is less than 0 means f is decreasing in 0 to pi by 2. So are you able to follow how to analyze whether a function is increasing or decreasing in a particular interval? Now you are looking at 0 to 2 pi, all the 4 quadrants, and you are given f of x equal to sin x plus cos x. So what will be f dash of x? F dash of x will be cos x. Derivative of sin x is cos x. Derivative of cos x is minus sin x. Now, f dash of x equal to 0 implies cos x equal to sin x or tan x equal to 1. That is x equal to pi by 4. Where all tan is positive, it is positive in the first quadrant and in the all silver teacups, third quadrant. Third quadrant means pi plus pi by 4, which is 5 pi by 4. So we can divide the real line or in terms of 0. Since we are interested in 0 to 2 pi, I can divide using pi by 4 and 5 pi by 4. Then we can write down the intervals sin of f dash of x and nature of f of x. Now 0 to pi by 4. Pi by 4 is nothing like, it is like 45 degrees, right? So I can choose 30 degrees, which is pi by 6. So let us look at f dash of pi by 6. What is f dash of pi by 6? F dash of pi by 6, what is f dash of x? This is cos x minus sin x. Cos pi by 6 minus sin pi by 6. Sin pi by 6, sin 30, which is half. Cos pi by 6 is root 3 by 2. You know that root 3 is approximately 1.732. So 1.732 minus 1.732 by 2. So it is greater than 0. Okay. So the interval 0 to pi by 4, the function is increasing. Okay. Next we have pi by 4, comma 5 pi by 4. What is 5 pi by 4? Pi plus pi by 4. Pi plus pi by 4. Okay. Now, I want to choose a value between these two. So, can I choose 90 degrees pi by 2? So, let me look at f dash of pi by 2. Now, f dash of pi by 2 will be cos pi by 2. This is the derivative, right? So, cos pi by 2 minus sin pi by 2. Cos pi by 2 is 0 minus 1. So it is negative. So it is decreasing. Now 5 pi by 4 is what? Sometimes we are comfortable with degrees. So I'm doing in both ways. This is pi plus pi by 4 or 5 to 25 degrees. Okay. So I can do between 0 to 2 pi, I can take 3 pi by 2, 270, 3 pi by 2. So what will be f dash of 3 pi by 2? F dash of f dash of 3 pi by 2 will be cos 3 pi by 2 minus sin 3 pi by 2. What is cos 3 pi by 2? For those who cannot remember, please remember sin cos 0 pi by 2. Okay. And then you have pi 3 pi by 2. I'm just teaching you how to remember. So it will be sin cos 0, 1, 1, 0, 0, minus 1, minus 1, 0, 0. You can remember this. 0, pi by 2, pi, 3 pi by 2, 2 pi, sine and cos. 0, 1, 1, 0. 0, minus 1, minus 1, 0. 0, 1. So what is cos 3 pi by 2? For 3 pi by 2, cos 3 pi by 2 is 0. Minus what is sine 3 pi by 2? It is minus 1. So minus of minus 1, which is plus 1. So the function is increasing. So it is positive and the function is increasing. So you have to show what values are substituting, because nobody should think that you are just guessing, right? So you have to validate your statements. So whatever values you are substituting, you have to show like this. Here I have shown f dash of 3 pi by 2 for here. For this interval I have taken pi by 2. So I have shown f dash of pi by 2. Between 0 to pi by 4 I have taken pi by 6. Here I have shown what is f dash of pi by 6. Then you can come to your conclusions. This is positive. Sorry, pi by 4 to 5 pi by 4 it is negative, so it is decreasing. Here it is positive, it is increasing. 0 to pi by 4 it is increasing. Pi by 4 to 5 pi by 4 it is decreasing. 5 pi by 4 to 2 pi it is increasing. So what are the critical points? Pi by 4 and 5 pi by 4. They are the values of x for which if I draw a tangent to the curve, it will be parallel to the x-axis. Is it clear? Now, f of x is tan inverse x minus x. So what will be your f dash of x? The derivative of tan inverse x is 1 by 1 plus x square minus 1. So 1 minus 1 minus x square by 1 plus x square will be minus x square by 1 plus x square. So f dash of x equal to 0 would imply x is 0. X square is 0, that is x is 0. So you have minus infinity to infinity and the critical point is 0. Now take any value here, minus 1. What is f dash of minus 1? I have to substitute here. Okay, f dash of minus 1. So when I put minus 1 here, minus 1 square is 1. So this will be negative. So the function is decreasing. What about 0 to infinity? Suppose I put 5. There also you can see this is x square by 1 plus x square is always positive. So minus x square by 1 plus x square is always negative. So what do you call this point 0? 0 is called the point of 0 is point of x equal to 0 is point of inflection. So there will be a tiny bend in the curve at x equal to 0, and it will have an horizontal tangent, but there will be a bend in the curve. Such a point is called point of inflection. In the earlier video, I had also explained this with the help of GeoGebra. Now f of x equal to tan inverse of sin x plus cos x on 0 comma pi by 4. So what will be f dash of x? 1 by, if it is tan inverse x, what is the derivative? 1 by 1 plus x square. Tan inverse of this, so 1 by 1 plus sin x plus cos x the whole square into derivative of sin x plus cos x, which is cos x minus sin x. So f dash of x is cos x minus sin x by 1 plus sin x plus cos x the whole square. Denominator is always going to be positive. Now, if f dash of x is 0, then tan x is 1, which implies x is pi by 4, or third quadrant pi plus pi by 4, which is pi by 4. But since we are restricted to the first quadrant, we are only interested in 0 to pi by 4. Okay. So if you look at 0 to pi by 4, let me look at a point here. Let me choose pi by 6. What is f dash of pi by 6? F dash of pi by 6 will be cos pi by 6 minus sin pi by 6. Cos 30 is root 3 by 2 minus half, which is greater than 0. So it is positive. So f dash of pi by 6 is positive. So the function is increasing. Now between pi by 6 to pi by 30 I have taken. This is 45. So what can you say? So we have values between x to pi by 4 only. So between pi by 4 I have taken pi by 6. So between 0 to pi by 4 the function is increasing. So since f dash of x is positive in 0 to pi by 4. So f is increasing in 0 to pi by 4. Closed into. So we have f of x is tan inverse of sin x plus cos x. If I differentiate, I get f dash of x is 1 by 1 plus sin x plus cos x the whole square into derivative of sin x plus cos x, which is cos x minus sin x. Denominator is always going to be positive. So I need to worry only about the numerator. 0 to pi by 4, you know cos x is greater than sin x. Pi by 4 to pi by 2, sin x is greater than cos x. Are you all able to follow? So 0 to pi by 4, what do you observe? F dash of x is always positive. The function is therefore increasing in 0 to pi by 4. Are you able to follow the problems that we have discussed today? We have done about 5 problems today. I want you to go through these 5 problems before we proceed with more. Okay, slightly more complicated problems, and we will in the next video we will discuss about what is the meaning of not just increasing and decreasing, but what is local maximum, local minimum, absolute maximum and absolute minimum. Okay, so we will do a lot of problems based on this concept in the next video. So until next time, it's goodbye. I hope you enjoyed this video.